Okay, so we're going to jump into a series of what we call lightning talks, so sort of shorter talks on a range of our biological indicators. We're going to start with Gabe Reyes, and he's a he's a biologist with the United States Geological Survey, the Western Ecological Research Center out of Dixon, California. Gabe's been working with us, I believe, on inventorying bats and doing mist netting and telemetry to find roost sites since 2017. And we're excited. We have an ongoing project with Gabe, and so we'll let Gabe tell you about bats at Mount Tam.
Cool, thanks for joining. Yeah, so my name is Gabe Reyes, and like Bill said, I'm with the USGS Western Ecological Research Center, and we've been doing a big project in Marin County since 2017. And I always like to just start out these talks highlighting how diverse bats are as a group of animals. So there's over 1,400 species currently recognized, and that represents about 20% of mammalian diversity. In Marin County, we have 13 species of bats in 2 families, 12 in the Vespertilionidae and 1 in the Molossidae. And this is just a little sampling of bat species diversity. So in our area, all of the bats are insectivorous. They're consuming insect prey, but within that, there's a tremendous amount of diversity as well. So you have some species like this little Eumamus, which is in my hand. And just to give a sense of how small that is, that's, you can see my hand, it's about the size of my thumb. And then this other species in the same genus, the Western long-eared Myotis, has these really big ears, and they're a gleaner, so they actually will pluck insects off of leaves and spider webs and things like that. Then we have some larger bats. So we have in this picture the pallid bat, which is the one that's kind of a pale yellowish color with giant ears. And that's a really large species of bat that actually eats, well, it can eat prey flying around, but also will eat prey that's walking on the ground. So they'll pick up scorpions and centipedes and Jerusalem crickets. And they're a really, really cool colonial species that we have in the area. And then the hoary bat, which is seen here hanging off on a tree, is a migratory solitary tree roosting bat. So those ones do long distance migrations up to Canada and down into Mexico. There's some evidence of migrations of over 2,000 kilometers, and those will roost solitarily just in the foliage of trees. So when we set up our projects in Marin County, bats were identified as a data gap that we didn't know much about. We don't really have good data on bat populations in this area. And so we wanted to study the nocturnal habitat use and foraging habitat associations, learn about roosting habitat, and then use different study methods to fill in data gaps. And this would allow for effective and informative long-term monitoring and management. And one of the main methods that we use is acoustic monitoring. So we go out to different sites and put up bat detectors during the summer. And these bat detectors are an ultrasonic microphone, and they pick up the echolocation calls of bats. So when a bat flies by, we can run the call through software and then manually verify and detect that a hoary bat flew by there, for example. And by moving these microphones around a number of sites, we're basically getting data on what species are using what habitats and what areas across the parks. And so this is a map of our detector locations. And so we're doing this monitoring during the summer when bats are most active. And we're covering pretty much representative areas across all of Marin County. And this data, this is just looking at trends in detection from 2000 and 2019, will allow us to look at trends over time. So we're looking at the number of sites that species are detected at, and then also their relative activity rates. And to that end, we're developing metrics to look at geographic diversity and then also stability of populations as measured through acoustic monitoring. The other primary method that we're using to study bats is using telemetry. So this is where we catch bats using mist nets and then attach a little radio transmitter. And you can see this one attached to California myotis. So these are really tiny little radios that emit a beep. And then we can follow the bats around and figure out where they're roosting during the day. So for example, this bat was found roosting in this giant fir snag up in Samuel P. Taylor. And we've been doing this work for 2 years now and hope to continue after we can start handling bats again. And we're just moving around to get different areas across Marin County open spaces. And for example, California myotis, we've tracked them to these really large snags, 50 plus meters tall. And then we've also tracked them to these down trees like this of the fallen over tree. This bat was just a couple feet up above the ground in this tiny little branch. And it returned to that exact location several nights in a row, or several days in a row, I should say. So this gives us really good data for learning about habitat selection, and then also this will allow managers to know what to look out and what to consider bat habitat. Another exciting finding that we've found through telemetry work during the winter time is we've caught several hoary bats, and this last winter in Cascade Canyon, we actually found a female wintering hotspot, apparently, where we caught several female hoary bats at Cascade Canyon and tracked them to trees. And that's a finding that's never been found anywhere before. So we were really excited about that. One challenge with studying hoary bats is when looking up at the trees to try and identify exactly where the bat is, you'll be staring at this with binoculars. It's really hard to get any sense of what might be a bat. You'll get excited, see something that looks like a bat, and then after staring at it for 5 minutes, you realize it's a pine cone. So they're very challenging to find and find exactly where they are. However, we are learning about what tree species they're selecting, what types of habitats, and then also their movement rates. And this is just to show we've tracked about 40 bats. We're doing this work during the summer and winter time. And so far we've studied 7 different species in this area. And we're tracking bats and finding that they're making lots of use of both structures and trees. And this is just to highlight that the parks provide really important foraging and roosting habitats, but these bats can fly and they move really big distances, and we're tracking them into neighborhoods, into houses, into people's attics, and then also into trees on the parkland. So that presents a really interesting case as far as thinking about how to manage populations that freely move between jurisdictions and in and out of park areas. So back to the future. We're hoping that this data will help us monitor and provide information to landowners as bats face emerging stressors into the future. So some stressors that they're facing are white nose syndrome. Like most wildlife, they're dealing with habitat loss and habitat connectivity issues, loss of insect prey. And something that's on everyone's mind right now is how climate change might affect bat populations. And in this area, that would mainly be through prolonged droughts and also the effects of fire. And we know from studies in other parts of California and also worldwide that bats tend to adapt pretty well to fire. They often move into areas that are recently burned and take advantage of succession. Booms in insect prey, and then also fires will scar trees that provide favorable roosting habitat. However, with really catastrophic fires, like we've been seeing recently, we know a little bit less about how bats respond to those situations. Fortunately for bats, unlike a lot of other wildlife, they can fly, and we know that they do flee fires. And then oftentimes our fire season happens after the maternity season. So that's also something that allows them to be a little bit more mobile. And then we're also interested in how larger regional impacts, like the development of wind energy, which has impacted hoary bats and other bats on migration, might be affecting bat populations in Marin County. So with these data, we're hoping to contribute to our own regional bat population monitoring. And then this is also going into the NA bat program, which is contributing to continent-wide bat monitoring. And this data will provide our local land management agencies with really high-quality, actionable data regarding status and trends of bat populations, and then also allow them to develop mitigation actions when appropriate. And this project has been a huge collaboration. I'd like to thank my funders, especially One Tam, Golden Gate Parks Conservancy, and National Park Service. And we've had a tremendous amount of input from staff from all of the agencies involved. And it's, yeah, it wouldn't be possible without all our collaborators. And yeah, with that, if we have any time, I'll take any questions. And if not, feel free to email me or type them in the chat and I can respond.
Thank you so much, Gabe. I've got one question here, which is where should people report bats roosting in house structures in Marin County?
Great question. So right now you can email that to me and I could provide advice and input. I know California Fish and Wildlife is starting to develop a bat reporting tool as well. And then we're also developing at USGS a bat tool or a community science bat population monitoring tool that we hope to unveil later this year or next year. And yeah, we're really interested in that data and we can get you involved in monitoring your bats that are on your property and contribute to this monitoring effort.
Thanks, Gabe. And one other tip for folks who have wildlife sightings that they want to share and want to make sure don't get lost is to make use of iNaturalist. So if you've got bats in your house and you can get a photo of them, you can always upload them into iNaturalist. And then folks like Gabe or other staff biologists, we periodically go in and download and make use of them for our studies. So thanks a lot for that. And with that, we're going to move on to the next speaker.
Thanks.